Okay, right. I'm recording my side, so we can always do two channel as a backup.
Okay, excellent. All right, let's roll. So, uh, problems. The hypercomputer credential management presented a few curls, but then I recognize I had to do a clean out or clear out of a bunch of the concept of faces because I realized that the concept of faces was wrong. And so I've shunted. I've done a conceptual shunt. And I drew a picture of this shunt. I shunted like this.
Okay, all right. Tell me about your nature of your shunt.
Why does it sound like it's just a massive shunt?
It's a Scottish thing. You always got to find some
Some
make it
stupid
sounding
shunt.
odd. Yeah.
Right. So the computer ID. I no longer know what computer kind means. I think there's only one computer kind.
What did it mean previously?
I don't know, honestly. I think it just meant like I don't know enough about this piece, so I gave it a kind because everything else had a kind.
Right.
But now I know about this piece, and this piece is very hollow. And so at the moment, it exists as effectively a folder. But one of the confusing things that I've been dealing with is it more than a folder? Because right now I've got it holding agents, repos, the executing machines, which I've renamed to hosts, and secrets. And I'm not sure that that's right to treat it as a folder, but the rule seems to be everything is an agent. And if it isn't an agent, it can't execute. And so the computer acting as a folder seems to fit that model because the rule is, I guess, no special things.
It sounds right what you're saying about the agent is the unit of execution. It seems
Right.
like there's a lot stuffed into a computer, though.
Well, yeah, there's a lot. That's the thing, though. Like, in an architecture, you always end up with something that's a little overstuffed.
Yeah, I guess.
But
yeah.
The computer is also a repo. So the fundamental unit of execution is the agent. The fundamental unit of storage is the repo. The computer is a special repo in that it has effectively what are repo submodules. So it has a list of, it holds other repos. And the reason is, if you just give me a mother fluffing second here. Oh man, how am I gonna find this? Standby.json. Please hurry up. I have people on the line. I don't have the patience all the time.
Why is it taking so long to search?
Look, if I don't know.
No, there's no answer to that. It just is what it is.
This is. Can't wait to get rid of this app and use ours.
Yeah.
Anyway, this isn't working. How else do I find the thing?
I'm trying to index first. Or something stupid like that.
Something stupid, eh? Yeah, whatever.
Okay.
Um,
Sorry, go back to where you were. So, computers have repos, and then they have what, sub repos? Is that what you're saying?
no. Like the computer folder is itself a repo, but as one of its folders within it, it stores a list of repos. And so that's
Yeah.
what makes it a little bit, because
That's
otherwise it's a unique thing, right? Like
yes.
if everything has to be repo.
Right. So I would call that context.
What? Why?
Um,
So
because there's a repo that's necessary to put itself into a running agent, but then there's the context about what the agent cares about, which could be shared.
yeah. So it's what the computer cares about. So the model I've pursued here is that in a computer, man, I really just want my file system thing. So annoying.
What you could really use is a hypercomputer that already knows.
Don't start with me, Maxwell. Don't start with me.
Sorry, that was an easy shot. The goal was clear. There was no harm. I took the shot.
This is irritating. How do I get this thing to do a thing? If I go Control P, index, re-index. No, I just want my stupid thing. Repo slash.
And this is the whole golden grail. You having to hold it in your brain about how to ask the right question in order to find information that you know it's there. And AI should be able to do that. This is what we're going for. This problem that you're finding right now. Um, Text is absolutely fine in terms of a way of storing information. Retrieving information from text sucks.
I just want to cry. Oh no, here we go. Oh, now I can't. Are you gonna really play me like that? Okay, here we go. This is the current mock-up of how the folder that is the computer works.
Right. Okay. So this is an at-rest folder
Yeah.
because it's not instantiated yet.
Well, that's the thing. In our system, I've come to realize that everything is at rest. A git commit is at rest. Work happens only within the mind of an agent. The mutable workspace of the agent is the only place that is not an at-rest thing.
Where does? Okay, I'll hold questions until you finish. Sorry.
All right. So the computer, the way I think about it is that there's this top level virtualized folder that doesn't exist that we refer to all the time called computers, which holds every single computer.
Okay.
That is how you allow one computer to talk to another computer because you assume that you're all in the same space.
Like an address space.
Yeah.
Sort of thing.
Yeah, but the address space is by public key of the computer. So you can you can act like no one's there. You can only see some people, some computers. You can't just see every computer naturally. But the way I think about it is that all the computers that you can see exist in a computer's folder, and that's how you refer to them.
Right.
Now, inside the computer folder, repos is the interesting one because repos is where you have folders that represent repositories that the computer is interested in.
That was calling the context, but yes. That's the
Yeah, context is too loose a term, and I'll explain why.
okay.
The model I was taking is that every time an agent boots
Uh-huh.
inside of its workspace, it has a. So we have agent.toml, which describes bits about the agent, but
Yeah.
there's also a workspace.toml that I made a sketch of to just sort of overly pack it with every feature that could possibly be in there just so I understand what I want.
Okay.
But basically, it's a way for you to make a configuration file that represents the context that you want the agent to have by defining it in terms of repositories.
Say that again.
The workspace.toml is a way to define how you want the agent's workspace to be configured. It
Right.
includes things like what repos do you want it to have access to? Do you want it to have access to the whole repo or just to part of the repo? Do you want it to have read-only access
Makes
or
sense.
write access? What folder name should it be put into the workspace as? All those kinds of things, and most importantly, things like what is the name of the branch that I'm going to make for you in the workspace, because the principle that we sometimes you and I talk and I'm like, should I make it this principle? And then you're like, yeah, sure. But those things always have consequences. One of the consequences of the discussion we had the other day, which is to say that an agent it only sees a repo in a dedicated branch. Yes, it can browse other branches, but in the workspace, it's got its own unique branch that it can make modifications to till the cows come home.
Yes. You can give me 2 minutes to
Sure.
explain why I keep on going down that route. What I'm trying to be consistent with is mapping this to how people work. And so it'll be a bit like explaining a task to someone, saying in an office, here, can you do this task? Here are the documents. There are other documents that you're not allowed to look at. So you've got permissions, credentials, and so on. Go off. Now, while they're going off and doing work, they're doing that in their own head. It's not committed anywhere. They come back and report, and then if that report passes whatever QA or something similar, then it becomes part of the received wisdom of the organization. So that's the basic. I'm trying to do is
Right.
map it to how people work.
Right. Now, just to check that there is no way for anyone to see what's in the agent's head at any point.
Right.
So
Exactly.
the way to report back or to complete something is to do a commit on the agent's own personal branch and then request it to be merged into the branch from whence it was forked.
Precisely.
Okay, good. So that's why you need this thing in here, which obviously these are all, I choose defaults for you by default.
Yeah.
Sorry, too many defaults there, but you can select the pattern if you want to set the naming convention for the branch.
Well,
of
that's
the agent.
sensible, because otherwise chaos.
Yeah. So what that means is these repos that you have in the agent workspace are not going to be true repos in the sense that they don't have the ability to push and pull and go outside, because my thought was that there would be tens of agents working on these repos at once. And so the idea, the model is that the repo, if any agent needs access to a repo, it needs to be cloned in the computer. And there will be a dedicated agent in the computer that maintains the latest commit of that repo. So it will check periodically if there have been new commits, it will fetch them down. Like there's
Right.
in a computer, there's basically one canonical version of the repo, and then there's a feature in Git called Git Worktree. Git Worktree allows you to make a checked out copy of the Git repo in one branch, but you can do that like 100 times so long as you use 100 different branches, and they all use the same Git repo backing it. And so all it's doing is just checking it out on disk, which is considerably cheaper, faster to do than to do a full Git clone into each agent every time.
Okay.
Because otherwise, when you boot the agent, if I have to pull it down from the remote, like GitHub, then you want to pass it over to another agent. That agent has to commit, push to GitHub, signal to the other agent, and then that agent has to do a pull.
Oh, that could get gnarly if there's a lot of agents.
It even gets gnarly if the repo is of a modest size, like perhaps you've got some images in there,
Yeah.
you know, and it starts to really hurt the NFS service. So that's why I adopted this policy of like, well, if the repo's here, that means that all the complicated configuration, like what's your GitHub password? What is the master branch? Where is the issues list of the repo? Like all those things are dealt with at this level. And then at the agent level, it only deals with, hey, I know what repo I'm in, I know what branch I'm on, I know what files I've got, and I know that I can commit to it exclusively, and that's it.
Right. I see what
So
you're saying.
the pushing and the pulling and the merging is the job of a dedicated agent that will be able to control this repo. But that's almost like a special job. It's not just any old agent can just interact with the I guess the master copy or the reference copy of the repo. That requires a privilege.
What happens if someone else updates the repo R1 while you've got your workspace thinking that it was R1 minus 1?
That's perfectly fine because your workspace is its own dedicated branch.
Mm-hmm.
And so all that you see is that if I pull down and I've got a whole bunch of new commits for R1, all of the agents see within their repos that there are new commits that they may want to merge, but they don't have to do anything about it.
Right. So inside your workspace, no other agents can reach in and say,
No,
"Oh, that's
no,
quite good.
no one,
I'll have that."
no.
That's entirely your working memory inside your brain.
That's your working memory, yeah. Now, we could allow you to walk into it, but I don't like that idea.
No,
Like,
I don't like that idea
yeah.
at all.
So
Because
the
it
only
could
way to
be
communicate out is to do a commit. Once you do a commit, then any other agent would find it easy to navigate the repo and check out, because you're all sharing R1, you can know of all the other branches of all the other agents. You just can't see their working files, the changes that they've made, but you can see all the commits readily and easily.
Yeah. What would happen if some other agent commits to R1, the workspace has been pulled into working memory and is now out of date. But what it's working on, the commit is relevant.
That's
like
just
getting-
that's just Git. Like you can still do the commit. You're in full control of that branch within your workspace. You do the commit, and then you deal with merging and pulling and conflicts and stuff after.
So this special agent would poll occasionally to the repo and saying, is there anything that's changed that's actually pertinent to what we're talking about?
The special agent would always pull from the remote, which an easy example is it being GitHub, and it would constantly poll it and be like anything new, anything new, anything new.
Yeah,
So
but
that-
it wouldn't have to pull down everything. It could just pull down anything that's relevant.
It could, but it's easier and perfectly economical to pull down everything. It doesn't change any of the checked out branches that each of the individual working agents are dealing with.
Yep.
So the way I would deal with that is that I would make those functions that do updates on R1, that would be an MCP server, and an agent would get loaded that had access to that MCP server, so that the agent isn't breaking the rule that its workspace is a branch of a thing. But, like, you can start it with a blank workspace and give it this MCP server that allows it to make calls on these repos, like update R1, fetch.
Yeah. Okay, so the reason I was going down that route is, again, with this mental model of an organization, you've got a whole bunch of engineers working on an engine, and there is, from head office, a memo that goes out saying, hey, we need to increase the horsepower by 10%. And I'm going, oh, shit. Okay, so I need to go and, number one, understand that there's been something that's been said that
Yeah,
impacts me.
I know what you mean, and
Yeah.
that's really just there are so many ways that this system could be arranged that I'm not sure which is the right one. What you have as a concern is an obvious concern, and so we will hit it very early on. I don't know if this design is the right design. I just know that it seems good enough and I can build it.
Well,
There may be others.
the design of this, again, it's very useful to have, just something to refer to. And as an organization, you've got a whole bunch of people with their own workspace,
Yep.
own working memory. This is what they think is happening.
Yep.
And when they're done their bit, they put it back, and everyone goes, "Oh, right, okay, well done.
Yeah.
You've done your bit."
And periodically they might get a notification being like, oh, what you were working on has changed. You need to deal with that. And they'll be like, oh, yes, I do.
Yeah.
And they
Yeah,
will
precisely.
they will know how to handle that. So the reason why I don't like that is because the fact that we have NFS at all is merely a stopgap while we wait for confirmation that our design is useful, and then we move to making it be backed by a distributed file system like Git.
Yeah.
And so the working model of Git, I tried to pick one that was as sort of little stuff that we depend on as possible, because even this model is horribly inefficient. If you had 100 agents, you now have 100 copies of the files in the repo. Yes, you saved yourself the copy of all the Git objects and the Git data, but you still had 100 versions of this thing. And so the thing I want to make for this is like it's instant. It's all virtualized. So that commit makes you think there's files there, but they aren't there. They're just reading from the repo until you change them, in which case now they're part of your workspace. And so like all the performance is very, very nimble. The memory usage, the disk usage is very light, and all that. And the thing is, there's like a bunch of, I guess, nuances that happen with that, like, getting notified when there's been a change or merging stuff in. And so it's kind of hard to walk the line between, okay, we got this full-fledged thing coming and now we need something that works now, and we don't want to do too much plumbing and mess around with it. So this was sort of the middle.
Well, the rule of thumb should use, as I think you're doing, using as few functions as possible.
Yeah, and that's why I do think it's important to have this repo folder, because that's how these repos might be canonical. Like R2 might be hosted nowhere else except this computer.
Mm-hmm.
It doesn't have to have a remote off on GitHub. And so if you want other computers to be able to pull from R2, you can't have them pull by being an agent because you're on separate computers. So you need to go computer to computer, so that, like, computer 3 would clone from computer 1's R2 repo and would stay in sync there. And then internally to computer 3, all the agents would be busy working on their individual branches and things like that.
Yeah, that makes sense.
So that's where I was heading with that one.
What will be dropped in terms of functionality by doing that? Is there anything specifically that decision not to have this functionality?
Yeah, it makes agents, an agent's workspace becomes much more internal to the computer, rather than if you allowed the agent to pull down the repo directly from wherever it may be hosted. Now the computer doesn't really have control over how that workspace got assembled or built.
Mm-hmm.
And the containment boundary of the computer becomes more perforated if you do that. But in this model, the computer creates quite a strong boundary where agents can only access repos that have been set up in the computer.
Right.
Now, during the working life of the agent, it could still do a git clone from some other place and pull in a repo to complete its job. But in terms of a workspace that gets provisioned for it,
it's always going to know what everyone else knows at that point.
The trade-off is it is very tightly coordinatable with the other agents on the computer, because they're all sort of sharing this repo. But that's also the downside as well. But it seems like that's the design that we want, is that agents work as a tight-packed group and communicate often.
Yeah.
So
yeah, I agree.
Yeah.
I agree. And this is a stupid question, but I'm just double checking. Children are exactly the same structure.
Child agents.
Yeah.
So I made it flat so that all agents are flatly named by their agent ID, and then parent-child relationship is held within the agent. So each agent has a link to its parent, and each agent has a link to its children, but they are all flat in this one folder.
That makes sense. Yeah, makes sense. Okay.
Okay. Yeah, so at self was going to be a special repo, which is the repo that represents the computer that you're in.
Okay, yeah.
So you can look at the past state of the computer. Another rename that I did is that I called the thing that runs an agent, which is like the Docker container or the Cocoa. The running isolated computer that the agent runs upon, I called it a host.
Yeah. And that is that. So that's part of the what repo is the host information in?
The host information is in the computer repo because
Right.
this directly relates to the hypervisor, or the thing that is in charge of the execution of the computing units that are supplying you, that are running the agents.
Right, and that computer repo also has. I think you mentioned that the credentials were dealt separately, but it has access to the computer agent that deals with credentials.
Say that again, sorry?
Um, so I have hosts a1.json running state, Docker image, and so on. There'll be credentials required for that.
Yeah, so what I was going to do there is that I was going to make a folder called secrets in the computer.
Yeah.
And this is where you store any kind of environment variable that is a secret that you want to insert into a host when you boot it.
Right.
And I think that would be specified in like the agent.toml or something, so you can sort of I don't have a good answer. I'm hoping that it shakes out as I build it, but somewhere in here you specify what secrets this agent needs access to, and then when the hypervisor is booting it, it reads from the secrets folder, reads the secrets that it's allowed to, or that it's told to put into the booting host, and it puts them in as environment variables so that when the agent's running, they're present. For a lot of things, that just works. Like for GitHub, if I put an environment variable in there named gh_token and it has a valid GitHub token, then all the GitHub tooling will just work. So when the agent calls gh push or gh pull or gh list issues, that tool will just work.
Mm-hmm.
So that model sits nicely with how a lot of CLI apps expect to receive their secrets.
Yeah, okay, that makes sense. So, again, that's inside the computer repo with many things.
Yeah, in the computer folder. I've just been calling it a computer folder because when I call it a repo, it gets collided with repos within the computer.
Fair enough, yeah.
But
okay,
so in the computer folder,
yeah.
there's a secrets folder that stores all the credentials that various agents running within the computer might need. And then the configuration of the agent specifies what secrets they have the right to access.
Right, and then those secrets, once the agent is instantiated, what comes first, the host or the agent?
I'm very pleased you asked that. So part of the holdup has been that I realized that the host, I used to make it that the host and the agent came together, but it's better if the host comes first and then the host receives an instruction from the hypervisor telling it what agent to load.
It seems that way, doesn't it?
Yeah.
I'm a bit shaky about whether that's right, but that seems
reasonable. I am not shaky about whether that's right, and I'll tell you my reasons for it.
Mm-hmm.
Part of the rename that I did was that the hosts, I had been confusing or blurring a host and an agent together in the code that I made, but really the host is just the Docker file, the image, the operating system, and all that runs.
Yeah.
And then there's a piece that has to run called a supervisor, where the supervisor. That's interesting. I can see your fingers as you unscrew the lid to
It's
the
interesting.
thing.
Yeah, I'm trying to stay hydrated. Lucozade. Very sugary.
Lucozade. What happened to Iron Brew?
No, that yeah. Turns out iron brewed actually dehydrates you. Too much caffeine.
Oh, I see.
So I'm on Lucozade.
Okie
A
dokie.
very fine and venerable brand.
That is a tasty beverage.
It's a tasty beverage.
So there's the issue that I struck in the last couple of days is that it became apparent that the host needs to maintain some sort of a secure zone, which is to say that the host needs to run as root, and then when it boots the agent, it needs to drop it down into an unprivileged user. Because if you allow the agent to be root, agents are likely going to be supplied by anybody.
Yeah,
so,
running agent as a root is a bad idea.
yeah, and you can bust the you can bust the infrastructure if you do that, either maliciously or accidentally, like some crazy ass model.
It's like running sudo in every command. It's like
yeah,
you
like
really shouldn't.
And then it's like, I'm going to reprogram the hypercomputer to fix this issue with my ping being slow. It's like, dude, just stay in your box. So that's why the host boots a supervisor, and then it sits there and waits to be told what agent to load, because the number of different agents will be greater than the number of different hosts. And additionally, the model within running Cocos is that it turns out booting a Coco VM is about 20 seconds, which is a little costly in terms of time. And so to do the model we want, we need to have them standing by. So you boot the Coco and you attest that the boot is correct and that it's ready to receive an agent, and then it gets, when the job comes in, it goes, hey, here's your agent, load it, go, go, go. And that's very fast.
So where is the hypervisor instructed from?
What?
Who tells the hypervisor that you've got these hosts and I've just been asked for this agent to be picked up? So a1.json, you're now running agent
well, that is the fun bit, because the model of the hypercomputer has a property, I think it's called self-similarity, but the hypervisor is able to be modeled as a hypercomputer. And so there's an agent within the hypercomputer that's active, running, that receives a request and can communicate with the hardware to tell it to do things, and it can communicate with the booted host to say, go, you're now going to run this agent.
Okay.
So in the Fly model that we've got right now, that's a specific app called this one, Fly Exec.
Yeah.
And how it works at the moment is Fly Router is the thing that receives, it does the HTTPS, it does the wildcard, it makes sure that a computer exists. If you land, it makes sure that a landing agent exists, and then it sends an instruction over to Fly Exec and says, hey, this computer, this agent, boot it. And then Fly Exec goes, okay, what was that? Okay, I needed, what kind of host? Okay, so here's the list of hosts that I've made. Host Basic and Host Coder. So I've only made 2 for now, but they are distinguished only by really the Docker file within them. So
all right, okay.
So Host Basic is the smallest fucking image you could get, and Host Coder has a lot more stuff in it.
Right. So then any agent that's running on Host Coder knows about that stuff.
Yeah.
Any agent working on Host Basic knows about that stuff.
Yeah.
And nothing else. And
That's right.
Shouldn't be able to bust out. Yeah. Okay.
That's right. And then that same supervisor is what sits there as an MCP server and receives the instructions from other agents like its parent saying, okay, start a new interaction. Okay, cancel that interaction. Hey, what was the result of this interaction? Okay, shut down. So it's like this control plane within the network that some agents are given permission to, and they use it to interact with the agent running on the host. But when the host first boots, and I apologize, it took me a while to work this bit out. It kind of did my head in for about a day and a half. But when the host first boots, it sits there and awaits an instruction. The instruction is, this is the computer ID that you're going to run for, and this is the agent ID within that computer that you're going to run for. Go. And then it goes out, loads that stuff, runs the agent. So I've made all these agent files, agent programs. So I've got the command agent, the codex agent, the inspector agent, and the test agent. And all they do is they boot up as an MCP server that the host keeps suppressed or protected. So the host will run it as an unprivileged user, and it's like this thing. When you program one of these agents, you can code it to do anything you like, but you're gonna be running as a non-root, and you're gonna be running as an MCP server, and you can do anything else you like, including like starting arbitrary processes, servers, dev servers, pinging the internet, do anything you like, but you're running as an MCP server and you're running as unprivileged. And that's the standard. That's the standard protocol. That the shape of that agent interface, which at the moment is very light, it's just basically halt, start interaction, await interaction, list interactions, and cancel interaction, and it's very, very low.
Question. It might be a namespace clash, but agent test doesn't have an agent.toml. Where does it go to get?
That is not a stupid question. There's only one stupid question I know of, and that is, when is it ready? So agent.test is supposed to be referred to by the agent.toml, where the agent.toml specifies what is to be the agent process. So I started thinking about where we had agent. We used to call it like nap, and you'd point to like an npm package or something, and then you'd have the tool within it. But really, it's actually the process now. So I'm like, this is how you specify what process the host is going to run for you that starts the agent. And so using these config options, I would point at like, okay, I want to run agent.test. That's what this agent.toml would point to. Or I want to run agent.codex. That's what a different agent.toml would point to. And then parameters for it are all the different config options that I might want that are going to be dependent on this code file. So like agent codex might have a range of different options, like the model, what tools are available, what config options are available. So that's how this program, you can supply many of them, and you can configure them arbitrarily, but they must be. You must tell me under the agent key in the config file. You must tell me like what kind it is. Like, is it a executable file, or do I need to run like Python to get it? You know how when you set up MCP servers and it's like you got to give it a command,
Mm-hmm.
or it could be anything really, and then this config file tells the host how it's going to boot the agent MCP server,
Mm-hmm.
and that's that. And that sounds simple, but that I ran around the bush a bit to find that.
Yeah, but then when it runs, it's encapsulated and
Yeah. Yeah, and now I don't know.
stuff.
Yeah, I think it's essential that we do separate the infrastructure control plane layer from the agents. So I think that we can actually operate with that. Like, we can actually treat these containers as not fully disposable. They have a bit of a blast protection property about them, but I think that we should be expecting to hold them integral. So the container expects to contain its agent, and that I feel like we can rely on that. It's a well trodden path.
That feels right, doesn't it?
Yeah, and if we don't do that, then we have made it impossible for people to trust untrusted code. Like, as a computer operator, a person with my computer, I expect my computer to be able to browse to an untrusted web page and run its code and it not take over my computer. I expect that. And so that's the same expectations I think that are fair to have of our system, that I can run untrusted agent files and it won't bomb my system.
I agree.
All right. Now, with this agent file, we used to think of, we would say tools, right? We were going to convert these all into MCP tools.
Mm-hmm.
That, I believe, still applies. And what will happen is that when this agent executable, when this agent MCP server is booted, I will also make a separate, safely contained MCP server that gets passed to that MCP server. You'll see why I took a while to get to this conclusion. It's a little loopy.
Mm-hmm.
But I boot the agent MCP server. I pass to it this tooling MCP server made up of all the tools that were specified in the agent.toml. So, for example, if I booted the agent codecs process,
Mm-hmm.
it would boot with an MCP server in it that had all the tools that were specified in the agent.toml.
Right.
So that allows you to, so long as you code it to know what I'm giving you, like you could make an agent that was blissfully unaware of the capability of the MCP tools that I'm trying to provide you as the agent. Or you could make one like the Codex CLI, where I know how to insert an MCP server into Codex, and so agent.toml is just specifying how the host will assemble this bespoke MCP server that was built up based on just the config, and then that gets given to the Codex process. And now whenever Codex runs, it has these special tools.
Yeah, okay, that makes sense.
Yeah. And then you control the agent with this MCP interface, but it's not the same. You've got these two, like,
yeah, you couldn't do anything weird like creating an MCP of its own parent process.
No, it wouldn't work because the process hierarchy in Linux stops you doing that.
Yeah. Okay, that's quite nice. That is quite beautiful, actually.
So I hit a couple of bumps in terms of time, but these are the conclusions that I've reached. I think they're okay, and it's now that I talk to you about them, it's a relief that I can actually explain them succinctly, because they kind of make sense. They're
Yeah,
just
the flow seems reasonable,
reasonable,
and
right?
the
And it makes use of agent.toml, and then it has these agent processes that can be arbitrary. They can be written in Go, Python, Rust, whatever, so long as they conform to the MCP standard. The host can boot them and interact with them and provide that control plane interaction. And then helpfully, each process can be given these MCP tools that it can interact with to give it special capabilities or focused harness capabilities, some of which may be remote. So you could have like remote MCP servers configured in the agent.toml that would be loaded up and presented to the running process, and now it can do those kinds of calls too.
and those remote can't hoist itself up in permission layers.
No, nothing can hoist itself up in permission layers.
Yeah, yeah, okay.
So
That's quite neat.
yeah, so the thorny kind of issue that I've worked around is that the model that we're running under is one big NFS file share. You don't want, and I don't think it's premature to at least consider this problem, but you don't want computers able to just browse into other computers, because that's bad.
Yeah.
So then we get to, well, how do you stop that, right? And now that's where this whole spiral came from, because there's 3 ways of running NFS. And I don't want to get sucked into too much down the NFS rabbit hole, because NFS is going to go away once we have the proper Git-backed version. However, NFS will still be there, but it will be on the host. So it'll run the server on the host instead of, at the moment, the server runs on a server. But when we have the fully virtualized version, the NFS server will run on the host, but it will fill its file system using these virtualized distributed Git calls to build up what the files are. And so NFS is semi-permanent with us. And the reason why it has to be NFS is because these CLI tools that have just exploded, you know, you got ones from OpenAI, Anthropic, Google, like everyone's in on the scene. These tools use the POSIX file system. NFS is an easy way to produce a file system in a Docker container that's arbitrary, like it's dynamic. You can fake it, you can do whatever you want in it. And so that's why I was like, the long-term solution is producing an NFS server that runs on the host that just mimics this massive file system. I'll skip ahead. At the moment,
the implications of that, but essentially,
well,
we're inheriting the structure and security of NFS.
Yeah, but the art for us, and you can call me out if you think I've gone too far down the weeds in some area. The art is to pick solutions now that fit the future model well, so that we can not. So it's more that we can have our thinking straight, rather than having to like do a bunch of stuff, build up a bunch of language and ideas and thoughts and theories and use cases and customers, and then be like, oh no, wait, we got to change this thing.
Yeah.
Now the art is not spending too long on it, because you can theorize till the cows come home, but I don't think I've spent too long on it. You can correct me if you like, and I think I've got them. Every time I present a model to you, it's because I think it works all the way.
Yeah, it feels right because we're effectively, I was saying, inheriting a whole bunch of capabilities from NFS. Let's
Yeah,
just deal with that. Now,
yeah,
does that map into what we're going to do eventually?
right. Now
Difficult to tell.
the hack that I've chosen to pursue
Hmm.
in NFS, if you there's three permission systems you can do. One is the server will just accept whatever your user ID is that you tell it. So if you say your root, it's like, okay, your root, and then it lets you access anything on the file share that is owned by root.
Okay, that's wild, but okay.
Yeah. The second one is a technology called Kerberos, which I used to break into when I was at university to gain admin access to the. Anyway, but that issue is around the host being a client of the NFS server has to prove to the NFS server who it is and therefore what folders and files it has access to.
Mm-hmm.
And then the third version is TLS, which is just like the HTTPS certs, does the same thing, just does it in a different way. Now, the reason why this whole spiral started was because those two options were too fucking complicated for me to want to dive into for our use case when they're going to get ripped out anyway.
Mm-hmm.
But then if I go with just the server accepts whatever the client tells it, I'm like, that's a no, that's okay so long as your client hasn't been rooted. Like, for example, if we have this model where the container boots and its root then deprivileges, de-escalates down to running all the code, then we trust that the root
I
service.
see your. Oh, okay, right. Okay, so
This is where this all came from, right? And
right.
it sort of it convinced me that we must be able to set up a control layer within each container that we trust. We can't treat the containers as completely disposable. We need to expect that some of our processes maintain their integrity and then they sandbox the agent within it. And I think that that's a reasonable thing to expect.
Yeah, yeah. Give me a few seconds. Um, so again, essentially, we're saying that they control we're escalating to something that we believe is secure, and so it can dictate to the NFS.
Yeah, it can report accurately. So when the client, when the agent process
Mm-hmm.
is running, it's running as a deprivileged user. And now the hack I was going to implement was that I get 4 billion user IDs under Linux. I was planning to give each agent a unique incrementing user ID
Mm-hmm.
so that each agent only had access to each agent's files.
Mm-hmm. Mm-hmm.
And so because we got the kernel on the root is secure on the container, when I boot the agent process, I set it to be user ID whatever got assigned to it.
Mm-hmm.
That means that when it goes to use the NFS share, it can only see the computer that it's allowed to see, the folder that it can see, the workspace, yada yada.
I mean, that seems reasonable, right? Because again, we're essentially saying, hey, NFS, are you secure? We don't really care. We're going to hold the security of the things, and it's going to be asking you stuff of.
Yeah, yeah,
That seems reasonable, doesn't it?
yeah. I don't know any other way around it actually. Like, you got to have this privilege because even when we move to the virtualized NFS, you still can't have given away your root integrity because then like all sorts of wild shit could be going on. Like there are some keys and some access that needs to be held secure on the host container while it's running.
Yeah.
Otherwise, you can easily lose access to a lot of stuff.
Yeah. Yeah. Okay.
So, took a while to map all that out, but that's the model I was going to run with. And I think that we can actually be commercial, like we can have customers and all that under that model, because we're like, well, we're relying on the Linux user model to be secure, so that when I de-escalate my permissions from root, that user is assigned a user ID that the NFS file system honors, and that's what gives you access.
Right. And I think actually that would be more comforting than, say, writing an entirely new way of doing this.
It's right. And then even when we move on to the virtualized model, we can still carry that principle forward. It's just that what a user ID is becomes now public key cryptography, as opposed to I had 4 billion numbers and I haven't run out yet.
That's a small step, right?
Yeah.
Relatively.
Yeah. Okay.
Okay.
And then the computer, I was going to use that as the group ID. So the agent has this user ID that makes it just that agent, and it belongs to the computer group, which allows it to access files. Some files of the computer are made available group wide, so all agents can see it, and they might have read only access or things like that. So I was just basically nestling inside of the Linux permissions model, and I think we can actually launch publicly with that model, because it's a pretty strong one and we're only using it very lightly.
It's quite easy to explain and understand as well.
Yeah.
Okay.
All right.
Yeah.
So that's the holdup. I feel like I've got through it, but man, that was just, I was like, oh my god, it's just endless. Like the MCP servers inside of MCP servers, and then like who started the host and now what. And so with that model, it allows us to do things like have a standby host, so I can like make machines ahead of time, which is less important now in Fly because it's like 2 seconds, 3 seconds to create a machine, but when it comes to Cocos and they take 30 seconds to boot, standby is essential. And so you can have a host that's booted and warm and it's just ready. It's just sitting there ready to be told what agent to run.
Yeah. I think that'll make your life easier probably a year from now. It also reflects on the thing you sent a few days ago around the anticipatory capacity on the use of power as the gold of a currency.
Yep. Okay, so just to recap the rename, computers are a folder that contains one or more agents. A computer must contain at least one agent, or it's like having a computer with no CPU. Is it still a computer? No, it is not. The agent has its own agent ID, which is equivalent temporarily to a Unix user ID. The agent has a computer ID, which is equivalent to its group ID. It has an agent kind, which means that at the moment you've only got these kinds, but we can make more. Kind seems like less of an important parameter to track now. It's just where to get the agent.toml file from.
And once it's instantiated, it's like, I've done it, but it does need it.
Yeah. And then status, I don't think I need that key anymore. Now, each agent receives 0 or more interactions, and the interactions are just simply like natural language calls, like here's a string, and then based on what the agent is programmed to do, the context that's given within its workspace, and the MCP tools that its agent.toml
Yeah,
contains.
it'd be more than just natural language though, because you could have an NCP call to something that was just bare code, couldn't you?
No.
Why not?
Oh, you mean using this? So you'd make an agent that was not AI capable, it was just a piece of code.
Yeah.
Yeah, okay, so that would still be a string in the same way that typing on the shell is a string. So in my shell, I type a string and then I press enter. That would be one interaction.
Yeah.
The reason why it's like that is because I can't figure out a neat way to make it have more shape than that. You know, like when the agents are running and they create a new agent, a child agent, if that agent was going to interact with them by ways that were like more structured than just strings, that starts to get kind of a little bit hairy. Like it's hard to. It's first of all, it's against the grain for the same reasons that we realized that having dynamic MCP tools was against the grain. But it's also, in a way, it feels it's. First of all, the you get an explosion of things that you could be talking to, right? So it's much simpler.
Thermometer, can you? Yeah.
Yeah, but then you also get it's not part of the agent model is about externalizing the intelligence. Like you don't. If I knew what tool call to make and how to make that tool call, wouldn't I just make it as the agent? You know, wouldn't I just make it to one of the MCP servers that was provided to me, or wouldn't I try and get that MCP server provided to me? You know, like there's the utility of the agents was almost to offload the thinking about something by handing out a natural language instruction.
Yeah.
Now, you could hook it up to a shell, but what I'd like to learn is why would you do that under what circumstance? So I've made a shell agent, which is agent command here, just as a test case. But what I'm hoping is that in practice, you don't really try to send, like, you in practice use the agents for their AI ability primarily. I know that.
I see what you're saying. Why bother learning a syntax of a command line when you've got an LLM who will just do it for you?
Yeah, that's sort of like that. Like now, I know that I was insisting that the design of the system needed to work even if there was no AI. That is true, but it's also like there is also AI, so it's about the design has to be pure enough that it could work without the AI. But since we do have the AI, I'm like, and the use cases are, you know, so that's one of the big experiments that we need to run, man. Is I think that works. Like agent to agent communication is always natural language, but
Well, it should work because it's well structured, and the models now are good enough to do well structured.
But that's something we have to keep an eye on. So we do have a plan for that if it doesn't work out, but it's complex. Like to make an agent that presents you back a range of MCP tools is almost the same as like it's doable, but it gets a little complex. Put it that way.
Yeah, fair enough.
Yep. So
Okay.
Yep, that's that. And that's kind of where I'm at, buddy. Some
Well, I like the way it's structured. It does make sense. I'll need to review this recording, but
that took a
on first
lot of
on first
time, man. Like
blush,
that
on first
that
blush, it seems understandable, right?
yeah, that took a lot of time, and that was not something the bots helped immensely by doing research for me. I was like, how do I implement Kerberos authentication in NFS? What is the time delay on a TLS handshake if I use that as the identity service in NFS? So the amount of research I was able to do using Codex was vast, but it still amounted to a delay in time for me. And then now I feel like I've got it all in my head. It helps incredibly talking to you about it because I'm like, oh, if I can explain it, then and it feels okay, then I think we're in a good position. And this is the model basically. Like,
Yeah, it's the bit I'm excited about is the idea of effectively virtualized AIs.
yeah, virtualized AI. Now there's one extra piece I realized that I want you to keep in mind here. At the moment, right, Codex runs as a CLI, and we are inserting the interaction model on top of it by just saying that you start Codex and then you push in a string, it whirs away, and then when Codex finishes, it has some output and it sends that back,
Yeah.
right?
Oh,
But
hold on a second. I've got a call. Where's that from? Okay, I can ignore that. Ignoring it. Yeah. Sorry, go on.
so, but in Codex, there's a lot of other commands and things, right? So in our model, an interaction comes in and it would say something like howdy. One interaction. The codex works, and then the result comes back. That's what gets returned to the caller, the agent that called this agent, right? But there's also other stuff you can do, right? Like I can go /status or /approvals, right? That doesn't is difficult and complex to fit into the interactions model. But then you've also got things like you've got Claude CLI, you've got the Gemini CLI, right? And they've all got these nuances. And so what I realized is that all the big players are putting out these very, very feature packed CLIs. And so all we have to do to be able to handle them is to insert a tiny little AI proxy that can read the TUI, can read the terminal output, and can do stuff like it. So the interaction comes into our tiny little AI piece that knows how to drive a specific UI, like the Gemini CLI, and it looks at the command and it says the command came in and it was status, and it's like, oh, I know how to do that. I go /status enter, and then I read the terminal and I send the result back. And
yeah, okay.
and so what I'm getting at is that with that simple addition, we can wrap any kind of TUI, however complex, in the interaction model, so that you could have the Gemini agent, the Anthropic, the Claude agent, and the Codex agent all doing different tasks, and you're still using agent-to-agent communication to talk to them all, and they're able to operate with the inner workings of the CLI, like the status, like the approvals, like changing these things that aren't easily hookable as interactions.
Give me an example.
If I want to get the status out of the Codex CLI, I currently can't do that using the interactions model that I just explained to you.
Mm-hmm.
But in this model where there was a small AI that sat and interpreted the command
Right.
first.
Gotcha. Because what I'd want to see, rather than remember, I need a forward slash and then status, and maybe I'd mistype that and so on. I'd want to be able to say something like, okay, give me your status, something along those lines, and it would interpret
Right.
it and then find out where to go.
Yeah.
Is that what you're proposing?
That could be used, but that was not the primary purpose of my suggestion.
Uh-huh.
The primary purpose of my suggestion is that each CLI tool that comes out has some meta commands that don't fit the interaction model. Now, requiring you to know those slash commands is sort of by the by because the AI agents could easily be prompted to have the manual with them, right? So they'd know what the commands were. But the problem is being able to, in an automated way, call those commands and get access to them. Like the Codex CLI exposes an API, but it doesn't give you, or it's hard to get hold of the status command. But as you can see, that's a useful command to have, right? And so what I'm trying to get at is a little bit subtle because I'm starting to think, not just in this example, but in plenty other things I'm starting to see, the thing to bank on is that you will, no matter who makes the CLI, and no matter how many they are and how advanced they are, they will always be built to interact with a human. They will always favor being driven by a human. And so for us to make these multiple autonomous agent models, if we made it so that we put a little AI on top of each one that effectively was interacting with it as though it was a human, it was reading the terminal output, it was putting in the command, and that little proxy sits there so that when our agent-to-agent communications come in, and one agent says, hey, Gemini CLI /status, and it gets received by our little AI shim, and it's like, oh, I know how to do that. I enter /status, and then I read the screen, and then I send that snapshot back. That's something that the Codex CLI, it would be very heavy to implement that. Like, we'd have to fork the Codex repo and maintain that fork to be able to get that feature, which seems so simple. It's right there. It's right there. I could copy and paste that as a human. But if we made the drivers of these CLI tools be a little shim that we made that was terminal UI aware, it could save us. Like, we could keep riding this compatibility wave forever. These tools will always be compatible with humans. If our shim looks and feels like a human to it, it would never know the difference.
Yes.
So that's really what I was getting at. And so at the moment we don't need that shim, but I wanted to make you aware of that so you're thinking about it as you come across problems in the interaction with the agents. There will always be features that a human can get out of the CLI that the remote model, the automation model can't. And when those features become compelling enough, that's when we can switch to putting that little shim in there, and we'll have all the features for all time.
It seems that shim shouldn't be that hard to do.
I know, right?
Just saying, hey, what version am I using? And do you know how to use it? And if I ask you something that implies that I want to use one of these commands, use that command.
Yeah.
Slash status.
Yeah. And so that, in a way, is like firing up our own little tiny codex CLI that can
Well,
pick.
that's tier 2, isn't it? I mean, that it's like lots of tier 1s, lots of tier 3s, and that shim is obfuscating the tier 1s in order to allow the tier 3s to get on with its job.
It's kind of like it's standardizing everything.
Yeah.
Yeah. So yeah, that was the only sort of little nuance that I'd sort of smacked into, that I was like, oh, you should be aware of that, because otherwise I end up writing code.
Yeah,
Code,
no,
you know, like
for what it's worth, I'm strongly in favor of that idea of the shim, because not only does it bring together a number of CLIs, it also offloads cognitive load from the human.
yeah. So the human's
Which
just
is
like
what
status.
This is all the is the whole point, and
The whole point.
And you can even see ambiguities being brought back. It's like status on what? Well, status on this part. So you don't need to have a mental model, or you don't need to memorize. And this is like a standing thing. You should never have to memorize any command line like / status, because that is cognitive load.
Correct.
You should just be able to express your intent.
Yeah, so there's some, I guess the gamble we're taking there, right, is that agent-to-agent communication, being pure natural language, can be erroneous and fuzzy, and then a bot will figure it out. If I'm like, hey, what's the status on that last call? The bot should know, oh, I go / status, and then I look at this thing, and then I might say some extra shit back as well.
Yeah,
right?
But also it's not hard to just mentally right now map out a number of agents that go, hey, our human just asked for a status. What's he talking about? Oh, right, okay, we've got the thread. Okay, he's probably talking about this. Because people's brains only occasionally jump between topics, and it's usually very obvious to AIs when you're jumping between a topic. I do it all the time. But when you're on topic, the context would point it to one of these shims, and going, oh, right, that's what you mean.
Yeah, I wonder if it's just our training, hey, like, because we got brought up amongst humans who weren't AIs and couldn't handle topic switches. We got beaten into staying on topic, and maybe an AI could.
Oh yeah, it is a brilliant switching topics. I do it all the time. The only thing is, you need to make it inquisitive, as in, now my confidence level of what I know, what the fuck you're talking about now.
Yeah. Okay.
It's low, and therefore I'll ask you a question.
Yeah. So.
Yeah, prompting. Yeah.
Agent-to-agent communication is natural language for now. Okay.
Yes, agreed. And actually,
does that bother you at all?
No. It's the whole point. In fact, if we get only natural language agent-to-agent communication to something really complex, that would be golden.
Okay, well, you kind of got that accidentally. Like, accidentally, it turns out I can't not give you that. Like, that's it's the only way I can get this thing to work. So,
well, luckily enough, that's the golden fleece.
How convenient. So yeah, I mean, my work is just getting the supervisor up right now, which is sort of took a while, but man, I think I got it. I actually had to do a technique I don't use very often, which was just delete it and start from a blank thing and start typing, and do that several times until I got it. And then
imagine doing that 10 years ago.
But yeah, so sorry, no hypercomputer, but it's In terms of when, which will be your next question,
No, I don't ask that question. That's a stupid question.
I'm
It's
getting very frustrated. Like, I feel like we should have the hypercomputer. I feel like it's in hand, but not. And it's kind of driving me a bit nuts, actually. It's making me angry.
yeah, yeah. You're just gonna have to get over yourself on that one, I think, because it's what is the important thing, not when. And yeah, we've got a cliff
Sorry,
face coming up.
that I did.
Everyone does, but the what is far more important.
I've actually, just while we're here, I've made it through a lot of these lists. A lot of these items, actually. Um, yeah, you don't need to be here while I do my bookkeeping. But I got rid of that too. Fuck, I've actually done a lot of work.
Yeah. Well, a question to you is: would it be helpful, or actual, you know, unhelpful, if we increase the tempo of these calls, or is the tempo good?
The tempo is good for now, but as soon as it starts to work, the tempo would be helpful to go up because I'm quite nervous about whether or not we got the model right. You know, like
Yeah.
it's
Yeah. But we need to kick the shit out of it. That's the thing. And to kick shit out of it, we need something to kick.
yeah,
Uh,
yeah. I
so
know,
there's
I
there's
know.
only so much we can do in the conceptual space. Well, I'm not saying that what you're doing is entirely conceptual because you've got code,
Mm.
but usage, I think, is going to teach us a lot. Um, and it's been a while before I've found problems with this route.
Yeah, it's been a long
And this
while,
far.
eh? Like it's kind of like
Yeah,
it's like as soon as we hit it, we're like, yeah, that's good, let's do it, and then it
yeah,
still looks good, let's do it.
yeah.
Um,
And there's the number of features that I'm very well, I would never use the word excited about. But I'm very keen on is the virtualization of agents, the isolation of agents, which gives you data sovereignty.
you mean the
Um,
confidential computing aspect of it?
yeah, and the movability of those objects,
Yeah,
uh, and that feels fundamental.
that feels
Um,
riotously good, right?
yeah, yeah. There's a lot of emergent behavior and capabilities that comes from that. I've been spending quite a lot of time thinking about those units, and it's just like you've got an intelligent thing here, and it's like I can give you this thing, I can attach this thing to something in the physical world. Um, we can mesh things together, and it's still a unit. It's going to talk because it knows how to talk to each other. I've got permission, so if I prove who I am, I can prove ownership of that thing. There's a lot that follows from having that virtualized agent, which just doesn't exist at the moment.
Hmm. Hmm. Okay, well, I must admit to feeling a little flaky about this thing, but I'll keep going with it. The reason I feel flaky is I struggle to believe that something so simple could be so useful, but we will find
Yeah,
out.
yeah, I get the same feeling, but it's mostly because
And it's
I
stupidly
was
simple. It's
oh,
like this thing could have been made 25 years ago.
yeah,
If you
I,
ignore the confidential computing bit, 25 years ago you could have made this.
yeah, I was born pessimistic, and so at the back of my head is like, Oh, really? Is that it?
Yeah,
Um,
and then it's like, well, what's really the difference? It's just a very small number of components that can repeat endlessly to provide you a computer that has no scale.
yeah, and it's self-referential and therefore is easily understandable,
Yeah,
and you can
highly
describe it to
integral,
someone. Yeah,
like can go offline, can be net split.
yeah,
And then we got the confidential aspect coming in as well. So
yeah. And then, in due course, we'll get the provenance piece.
yeah.
Um,
Oh well, fuck it. Oh,
mm,
we'll finish it off. But man, it's just weird.
yeah, it is a bit. We'll have made a mistake, but not a big one, I think. I can't spot it for the life of me.
Uh, are you interested in? Are there any questions that you have before I move on
Uh,
to something a
no, no,
little
I've been asking
more
them
humorous?
all along. Yeah, no, I've been
Okay.
asking them along.
There was a Cocoa breach 2
Yeah,
days ago.
was that the thing you sent over? Those physical, yeah, that thing. I looked at that, and it's like, okay, so um, uh, that does demote the what you can claim for Coco down to physical access, but physical access is something we know about, right? Guys with
Yeah,
flip cards and that sort of thing. It's just unfortunate.
which is annoying. But so it means that in a way it's good because now this is fixable by AMD and Intel, but they have to design how they do it differently. So it'll be like another couple of iterations on silicon.
Yeah,
But it's coming, right? Like all these are all like, back in the day when there were hacks on fucking networks and then hacks on HTTPS, and it's just
yeah, but
it's
there's not lost anything. It's just not gained where it could have. It's the same as someone getting into a data center and plugging anything into the back of a server.
yeah, right, or tapping
It's
your
that kind of
switch.
thing.
Yeah,
Yeah,
it's not. But it's interesting that AMD and Intel both say that physical access is not part of the threat model, which is
well,
probably the big thing, right?
it evidently is. I read the
Yeah, because
paper
but
and it's
they
like,
need to change how they. I'm sure that they will change how they code it. But it's not there now, and I mean this is all part of a technology maturing. Like you have to have these kinds of things for it to become
yeah,
trusted.
yeah, because unless there's a mathematically provable way that someone in the workshop can't solder something together, give them full access to the server, and no matter what you come up with is not going to make any impact, then we're not going to be there.
Well, that's what's annoying though, because it's like if you just encrypted differently, this wouldn't work.
It struck me as it doesn't seem that a fix for this would be hard, so I'm surprised
I
that
know. Yeah,
it was exposed.
the reason why the fix is hard is because AMD and Intel need to change their silicon for it to happen, and I think it can introduce overheads to the encryption that are higher than they had gambled for. So
Mm.
I think what's
Hmm.
happening is that they're using the same encryption key for each line in the RAM, and they're not changing it each time they're not doing integrity checks or any of the other types of stuff.
Hmm.
It's not full blown encryption that assumes that the RAM is bad. It just says, well, you can't the hypervisor in software can't make sense of the RAM, but it should be
Yeah.
treating it like a message over the internet, effectively, where it's like it needs
Well,
message.
each component. Yeah.
Yeah,
Exactly.
yeah. But what's frustrating is that if you ignore this attack, if you never went out to RAM or you used, say, only the level 3 cache in the CPU, which in some of the AMD chips is up to a gigabyte, then you could actually claim physical safety. Like, it's like you can't bust into that chip unless you know how to grind back the top, tap the silicon, interpret what's happening in there in a way that didn't break it, all those things.
Yeah.
So it feels like next iteration or two, and we should have genuine full-blown Coco. I'm sure of it.
Yeah. And when I was reading this, I was thinking about the practicality of this attack. It requires a lot. I mean, someone would have to be pretty, on it in order to exploit.
Yeah, and I think it's also brittle. Like, it's not. I think it's got a few quirks to it. But also, it seemed like it was hard to do for DDR5. Like, it was something about because DDR5 operates at a much higher frequency, that distance is hard to, like the length of the wire starts to matter more. So the faster the RAM, the less your ability to put something in the middle.
Yeah, because otherwise you lose the benefit of the faster RAM.
Yeah, it was all sorts of things like that. But anyway, that's the situation there.
I'm not too worried about this because and this is an assumption, but AMD and Intel spent a lot of money on doing this, and this is public knowledge. I'm sure that
they're
someone
gonna
on
get
this.
around it. They're gonna get around it. Yeah.
And it seems the word you used there was a good one, brittle. It wouldn't be too hard to knock out some part of that chain. Now, whether that's kicking the can down the corridor a bit, yeah, probably. There'll be something, but I wasn't too worried about it, but I was interested in that we kind of want more of these.
That's maturity. That's what maturity looks like.
Yeah.
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 All right, and the last thing was, I saw this article about concierges. So if we actually got into the concierge business, there's a lot of places that would buy that product from us. Like a lot.
Yeah.
So anyway, something to think about. I mean, I think we all want a concierge.
Well, in many respects, being married gives you a concierge.
No, it makes you a concierge.
Or makes you a concierge. Yeah. But it's definitely a valuable thing. It's like, hey, could you just ...
I don't remember the exact.
My kids are concierges in many ways.
Yeah, but that's it for me, buddy. I just keep going, man. I'm like,
yeah,
struggling a bit, but yeah, it's you can see it coming together. There's a lot of gnarly fucking curves on it, but yeah, I think I got it covered.
Yeah, nice one. Keep going. All right. Yeah. At the any point, just see when to turn up the frequency.
Okay, thank you. I expect it'll be soon. I long to make AI calculations that run all night. I feel like that's coming up soon.
Yeah.
Dev Day tomorrow. OpenAI in around about 8 hours time.
Yeah. Well, let's see what they come up with this time. Last time was deeply disappointing.
Yeah, well, this time apparently it's all about AI agents.
Okay.
So, and I think they're going to be releasing some big bits of infrastructure that let
anyone
agents...
got any good foreshadowing that you've seen? I've not seen anything other than it's happening. I've not seen any leaks.
No, I don't know. It was just a guy that sits across from me was like, "Hey man, tomorrow AI agents." I was like, "Oh, okay."
Yeah, no, I've only heard the headline, but I've not heard any leaks.
Yeah,
Guess we
okay.
can wait 8 hours. Well, that'll be in my daytime, so um, I'll watch that, see what comes from it, and hope they don't go full blown Californian PR nonsense about the colors of the fucking,
Yeah, I know.
really,
I know.
which is that was depressing when I saw that. All right, okay, so let's leave it there.
Yeah, I'll stop recording. Somehow.
Yep.